Hi, everyone. Thanks for coming. My name is Max Ross, VP of Engineering at Roblox. I lead our infrastructure team. I've been at Roblox for about a year and a half, 15 years at Google before that, mostly working on GCP serverless products. I'm passionate about making developers more productive by building infrastructure that's reliable and easy to use. Today, I'm going to be talking about a 73-hour global outage that we experienced late last year. If you'd like to learn how a multi-day outage can turn conventional reliability wisdom on its head, this is the talk for you. A little bit of info about Roblox before we jump into it. Roblox's mission is to connect 1 billion people with optimism and civility. We enable anybody to imagine, create, and have fun with friends as they explore millions of immersive 3D experiences. All of these experiences are built by a global community of developers. Some stats, just to give you a sense of our scale. In July, we had over 58 million average daily active users. Total 4.7 billion hours of engagement. We've got 23 edge data centers, 2 core data centers with over 40,000 servers. There's a lot of traffic hitting our front door, 20 million requests per second. And we've got a fully managed cache inside that core data center servicing 120 million requests per second. As you can imagine, this level of scale provides some pretty interesting engineering challenges. So we're going to spend a bunch of time talking about the outage, what we've learned, what's happening next. But first, I want to give you an overview of Roblox Architecture so that you have some context as I start getting more into the details. On the client side, we've got the Roblox app, which runs iOS, Android, Windows, Mac, and Xbox. If you're playing a game or enjoying an experience that's hosted on the Roblox platform, you're doing it using this app. On the server side, we've got 2 layers deployed in 2 types of data centers, edge and core. We run most of our server-side workloads on our own hardware that we procure and manage. We're not anti-cloud, but we are mostly on-prem. The primary thing running at the edge are our game servers. The game servers, they're responsible for physics simulation, hosting the multiplayer experiences that have been built by our community. When you're in one of these experiences, the Roblox app is mostly communicating with the game servers running at the edge. We've got 23 edge data centers distributed around the world. If we have an outage in one of these edge data centers, it's not a big deal because we've got 23 of them. That leaves us with the core data centers. And what runs there is basically everything else. This is where the persistent state lives. This is where our business logic is. It's also where we host runtime and management services that we expose to our external community of developers and creators. At the time of the outage, we only had 1 core data center that was fully operational. So the key thing to understand is that losing an edge data center was annoying but not a big deal, but losing a core data center was a very big deal. And that's exactly what happened. Okay, the Halloween outage. Global outage started October 28th, 2021. Took 73 hours to fully resolve. I can't possibly cover a 73-hour outage in the 20 minutes I have to talk to you today. So instead, I'm going to cover it in under 5 minutes. Don't worry, many of the details I'm glossing over in the write-up we published earlier this year. Your preferred search engine will find it easily. All right, let's do this. 73 hours in under 5 minutes. When I walked us through the architecture, I said we've got the client, the edge data centers, and the core data center. The outage took place in the core data center. We use a trio of products from HashiCorp called Nomad, Vault, and Console to run and manage the services in the core data center. We use Nomad for container orchestration. We use Vault for secrets management, and we use Console for service discovery, basically a mechanism for backend services to find one another so that they can communicate with one another. There is effectively 1 HashiCorp deployment running all of our backend services in the core data center. Several months before the outage, we started to enable a new console feature called streaming. And it was designed to reduce system load. The initial rollout went well, so we started turning the feature on for more and more services that talk to console. 24 hours before the outage, we turned this same feature on for our load balancers. Now, the size and shape of this particular workload triggered a performance issue in console, which eventually made service discovery unavailable. And Roblox can't run without service discovery. This was a classic single point of failure induced global outage. I've seen them before. You've seen them before. Single points of failure are bad. We know this. But here's where it gets interesting. First, we didn't have monitoring and alerting that would have pointed to the performance issue building up. The system was running pretty smoothly for the first 24 hours after this console feature was enabled on the load balancer. So from our perspective, that config change to enable the feature was a success. When alerts started to fire, we asked ourselves what changed recently, but unfortunately this change was no longer on our radar. Second, as service discovery became unavailable, our services kept trying to perform service discovery lookups, which failed, which eventually caused services to be marked as unhealthy, which caused them to be rescheduled, which put more load on console, which was already struggling, and so on. And console ended up with an enormous backlog of changes that it was not going to be able to process. And why wasn't it going to be able to process this backlog of changes? Because of a second performance issue buried deep inside an open source storage library that console uses. And this performance issue only gets triggered under particularly extreme workloads. And unfortunately, the workload generated by Roblox at our scale, as service discovery became unavailable, that triggered the second performance issue. So to summarize, just to make sure you're all with me, when we first realized there was something wrong, there were two separate undiagnosed performance issues. And since the second performance issue was a result of a persistent backlog of operations caused by the first performance issue, solving the first performance issue wasn't going to address the second one. We were going to have to figure out both of these issues and remediate them. It took 50 hours to find the first issue and roll back the console change on the load balancers. It took a long time because we didn't have the right monitoring, and because we had a few theories that looked promising at first but didn't pan out. It also took a long time because we're human and we got tired. More on that later. It took an additional 4 hours to identify and work around the second issue. We didn't actually get root cause on this one until after the outage, but that was fine. We were just happy to have a workaround. So, at that point, we were 54 hours in. We had a healthy Hashi stack, but because Hashi stack is the foundation for all the other core data center services, we basically needed to relaunch Roblox from a standstill. And that was not something we had experience with. We had to figure out how to do this in real time while we were all exhausted, and we ran into a number of unexpected challenges along the way. The relaunch alone took 19 hours. All told, 73 hours of downtime. So now that I've taken you through the outage itself, I want to share 3 things we learned from this experience that I hope will be helpful to all of you. Here's the first thing that we learned. Hero mode is dangerous. Imagine you're a runner who specializes in the 400 meters, 1 lap around the track. Now imagine you're running the 400, but as you approach the finish line, there's an announcement. The race has been extended. You need to do another lap. You figure, okay, I've got another lap in me, so you do another lap. But then as you approach the finish line, the race is extended again, and then again, and then again. And it turns out that today's race is actually a marathon, but nobody told you. How many laps would it take you for you to change your approach to the race? At what point would you decide that it's probably not just 1 lap, and you should really start treating this like a marathon? Hero mode is the belief that you're almost there and you just need to push a little harder. And it's dangerous because on those rare occasions when the finish line is actually much further away than you thought, you're going to burn out. And that burnout is going to make it much more difficult for you to finish the race. Let's put the analogy aside and come back to reliability practices. 4 hours is a long outage, right? Nobody wants one of those. But in terms of human stamina, 4 hours is manageable. Even if we're tired, even if the outage hits right before we're about to go to bed, we can drink some Mountain Dew, espresso, we can keep making progress. The challenge with this outage was that 4 hours turned into 8 hours, which turned into 16. And at that point, everyone was exhausted and not thinking clearly. We were in hero mode. We all still thought if we pushed a little more, we'd find the problem and restore service just like we always do. And of course, we all want to be there for that triumphant moment when we find the problem, and it's high fives all around. 1 more lap, right? Our exhaustion slowed down our debugging, and it also slowed down our ability to recognize that we were running a marathon. So what do we take away from this? The conventional reliability wisdom with a major outage is that you want all hands on deck. You want everybody working as hard as they can until the service is restored. And the reason that's the conventional wisdom is that you will almost always get the service restored before everyone burns out. But here's the multi-day outage wisdom. We ended up establishing round-the-clock rotations for all the major areas of the system. At that point, it wasn't all hands on deck. It was some hands on deck and some hands getting rest. We also tried to evenly allocate our deepest experts across rotations so that we could have at least one of them debugging at all times. It's really counterintuitive to ask some of your best people to stay away during an outage. But when you realize it's a marathon, this is something you need to do. We also set up an executive level rotation to make sure that if there was some disagreement that needed to be escalated, some particularly important decision that would benefit from exec input, we wanted that to happen immediately. So in retrospect, we waited too long to set up these rotations. I know I personally stayed engaged in the initial incident response beyond my own point of effectiveness. It was just so hard to log off. That's the danger of hero mode right there. So my guidance to all of you, it's extremely unlikely that your next production outage is going to require multiple days of round-the-clock debugging. But if the outage stretches on past a few hours without a clear path to recovery, you should at least have a conversation about setting up rotations. It's not an easy decision to make, but the quality of your decision-making is only going to get worse as you get more tired. So try to set up your rotations and send people to bed before everyone is too tired to think clearly. Lesson number 2, the importance of infinite undo. Most production issues, they're caused by engineers introducing change into the system. It's new hardware, new code, config changes. That was the case with this outage, but with the added wrinkle that 24 hours passed between the config change and when we started to see real impact. We looked at all recent changes, but we didn't go back far enough. I want to try and explain why, not as an excuse, but just so that everyone else can learn from it. Rollback first, this is not a new concept, but it most often applies when we make a change and then immediately start seeing errors. What about errors that aren't obviously correlated with a human action? You might still roll back first, but there are a bunch of other scenarios that you probably want to consider. Did we bump into a new scaling limit? Did a user do something we didn't expect? Is there a hardware or networking issue? Did some change we made a while ago light a fuse that eventually pushed the system into a degraded state that we're just now becoming aware of? So that last one ended up being the case with this outage, but in my experience, that's the least likely scenario of the bunch. And a 24-hour fuse, that's particularly unlikely. We didn't look at the last 24 hours of changes early on in the outage because our experience told us that the root cause was much more likely to belong to one of these other categories. And so that's where we focused our attention. So what do we learn from this? The conventional reliability wisdom is rollback first. I'm a huge fan of this practice. If there's a clear correlation between a human action and the errors, by all means, start rolling things back right away. Now, if there's no clear correlation, but you can still quickly roll back all the changes that went out in, the last 30 minutes or the last hour, and you think that might help, go for it. Maybe you do these rollbacks while you're pursuing other theories in parallel. I think it's a fine strategy. But should you roll back 12 hours or 24 hours of changes in the early stages of an outage without any indication that the problem has been brewing for that long? That's a pretty extreme call to make. If you've got tooling to make infinite undo really easy, maybe you pull this lever more aggressively. But during a normal outage, this is probably not something you're going to do. But this wasn't a normal outage, and we didn't need conventional reliability wisdom. We needed multi-day outage wisdom. The guidance I'll give you is the guidance I wish somebody had given us several hours into our debugging. If you're multiple hours in and not confident in the source of the outage, just roll it back. All of it. Don't be picky. There's clearly a problem in your system that for some reason you can't find. And so there's absolutely nothing wrong with applying brute force rollbacks to see if that's going to resolve the errors. Go back an hour, go back 4 hours, go back a day, go back a week if you need to. These rollbacks, they might not be your most intelligent theories about what went wrong, but at least they're fast to evaluate. Now keep in mind, rolling back all the configs to an earlier state can be relatively straightforward, but you might have a harder time getting back to an earlier constellation of deployed binaries, especially if you've got a complicated system. You might need to invest in tools to make this easier, But don't let a lack of tools stand in the way of doing it if you find yourself in this situation. Moving on to our third lesson. Graceful degradation has its limits. Here's a question. When was the last time your entire system wasn't running? I don't mean individual components. I really mean the last time the entire system, top to bottom, wasn't running. For many of you, the answer might be the day we launched. And that day might be a year ago, 5 years ago, 10 years ago. If you had to get your system running today, from scratch, in production, would you know how to do it? Would the process be smooth and automated? Or would it be trial and error? The reason I'm asking you these questions is that with most outages, if you've implemented standard patterns for graceful degradation and self-healing, your system will probably return to a healthy state on its own once you remediate the issue. You may sometimes find a few things that need to be manually reset, but it's unlikely to be your entire system. Now with this outage, we were down for so long that large portions of our system were unable to self-heal. We had to rebuild large portions of our production deployment to get back to a healthy state. And since this wasn't something that we do on a regular basis, it took us a long time, 19 hours. There's another interesting dimension to this. Maybe not all of you are aware, but people really love our product. If somebody wants to hang out with their friends on Roblox and Roblox isn't up, they don't just put away their tablet and try again next week. They try again and again and again. And then maybe they have lunch and then they try again. My point is, even when we disabled access to our systems at the front door to our network, we still had a lot of traffic still trying to get in. And that made our recovery harder. The issue wasn't the scale of the traffic trying to come in. That was manageable. The issue was that the system was cold. We can handle 20 million requests per second. We just can't go from 0 to 20 million requests per second instantaneously. So on top of having to figure out how to rebuild our production stack, we also had to assemble a DNS steering mechanism that gradually admitted users into our system. This is now a built-in feature of the platform, but it's something we had to develop on the fly as part of restoring our system after the outage. So the conventional wisdom is that if you follow standard patterns of graceful degradation, your system has a good chance of self-healing once you remediate whatever went wrong. But with a multi-day outage, the likelihood of self-healing goes down, especially if the outage involves foundational systems that are responsible for running all your other services. Here's the last bit of guidance I'll leave you with. Have a plan for how you'd rebuild your production stack if you needed to. This is not something you want to have to figure out in real time. Even better than a plan, have automation that can do this quickly. And unless you've got complete control over your users' behavior, don't assume you get to have a gradual ramp up in traffic once you've restored service. Now that I've shared some of the things we've learned, I want to talk about two major engineering efforts that are part of our continued reliability journey at Roblox. The first effort is we're on a mission to remove single points of failure. Hardware fails, software has bugs, users do unpredictable things that break your system. The goal can never be to have a perfect system because there's no such thing. However, if you can minimize the number of single points of failure in your system, you're going to have a system that's more resilient to all the things that are guaranteed to go wrong with it. This is the main thing we're working on right now, and we're tackling the problem in two different ways. The first way we're removing single points of failure is within regions. I said at the beginning of the talk that we only had one deployment of Roblox within each core data center. We're changing that so that we have many much smaller Roblox deployments within each core data center, and each of these deployments has an independent failure domain. We call each one of these deployments a cell, and we need to scale up. We just scale up by adding additional cells. This prevents any single Roblox cell from getting too big, which makes it less likely that the workload handled by any particular cell is going to trigger an extreme scale corner case like the 2 that we ran into during this outage. It also means that if one of these cells fails, we can quickly redistribute the load to the other cells in the region. The second way that we're removing single points of failure is across regions. We expect whole region failures to be rare, but we still want to be prepared for it. So this has been a big focus for us as well. We're still mostly running out of just one region at a time, but we now have our second region deployed. The next big steps are moving to multi-region storage and shrinking the amount of time it takes for us to fail over from our primary core data center to the other core data center. Today, this is a manual process, so it takes more time than we'd like. But the goal is to shrink the failover time to basically zero. At that point, we'd be running active-active storage and compute, serving users from multiple core data centers at the same time. This will take a lot of work, but we're excited about it. So the second project, as part of removing single points of failure, we're creating a large number of much smaller instances of Roblox. If we have to build and manage these instances by hand, it's going to take way too long. So we're making a big push on what we call turn-up automation. The idea is that when we need a new instance of Roblox, it shouldn't be a big deal. We just push a button, we get a new instance. This helps with cells. This also helps with building new regions, building new pre-prod environments. Also helps with outage recovery, because if for some reason your system does not self-heal, now you've got an automated way to get into a healthy state. This kind of automation requires a pretty large investment, especially if you have a complicated system that you've been building for over a decade. It can be tempting to say, well, building the automation is going to take a long time. I really just need one more environment, so I'll just build one more environment by hand and do the automation later. The nice thing about our cells project, though, is that the goal really is to have a large number of cells in each of our regions. And there's just no way we can do this by hand. We need to invest in automation to make the project successful. We're working on this right now. Our goal is to be able to turn up 2 cells using automation tools by the end of September. Then we'll start migrating workloads into those cells, and then we'll keep building from there. This turn-up automation is a critical part of our reliability journey. Some parting thoughts. There's one other thing we learned from this outage. We learned who we really are. Roblox's mission is to connect 1 billion people with optimism and civility. And we really do have a strong emphasis on optimism and civility. It guides how we treat our community of players and creators. It also guides how we treat one another as employees. When everything is going well, it's pretty easy to be optimistic and it's pretty easy to be civil. The real test is how we treat one another when things aren't going well. Something like a major outage is an opportunity to learn whether your mission, your culture, your values are just words on a page or something that everybody actually lives. I'm going to read just a few lines from the postmortem we published earlier this year because I don't have any better words than what we originally wrote. At some point during a 73-hour outage, with the clock ticking and the stress building, it wouldn't be surprising to see someone lose their cool, say something disrespectful, or wonder aloud whose fault this all was. But that's not what happened. We supported one another, and we worked together as one team around the clock until the service was healthy. We're of course not proud of the outage and the impact it had on our community, but we are proud of how we came together as a team to bring Roblox back to life, and how we treated each other with civility and respect at every step along the way. I'll leave you with one last thought. Most of the actual outage is a blur for me, but I have a completely clear memory of an engineer doing the world's silliest magic tricks with an avocado at 4 a.m. to try and keep everyone's spirits up. This engineer owned a set of services that were down and that he couldn't even try to bring back up until we'd figured out the lower level performance issues. He didn't need to be there on Zoom with us, but he was. He wanted to make everyone feel better. It was an amazing thing to see. This outage was an incredibly difficult thing for our team to go through, but I'm grateful for the experience. It brought us together, and it showed us who we really are. Thanks for listening.